Okay, that's the question. Not much to go on. We've been given a simple triangle, right-angled. We're told what the area is and we have to find the perimeter to three significant figures. Okay, well, first thing we're told is the area is that. We know two sides, it's a right-angled triangle, so we can get an equation for the area and set it equal to 2.5. So let's start there. The area of this triangle is going to be half that times that. So the area of the triangle is a half of that times that. It's a half because it's a right angle triangle. If it were a rectangle, it would be just x times x minus 2, but because it's a right angle triangle, it's half of the rectangle, so it's a half. That's an algebraic expression for the area, and we're told that that is 2.5. Good. We have one equation with one unknown, x, so we can work out what x is. Let's do it. Multiply both sides by 2. I don't like that 2 on the bottom, so therefore we get x times x minus 2 equals 5. Multiply out the bracket, therefore x squared minus 2x equals 5. Therefore x squared minus 2x minus 5 is 0. Okay, we've got a quadratic. So, how do you work out x when you've got a quadratic? First thing to try is to see if it can be factorised nicely. Okay? So, there's no number there, it's just 1x squared, so we're going to get an x and an x there. Right. We're looking for two numbers to go here and here that multiply to give that number and add to give that number. Is it possible to come up with two nice integers that satisfy these requirements? Well, the only integers that multiply to give minus 5 is going to be some combination of 1 and 5, like minus 1 plus 5 or plus 1 and minus 5, because 5 is a prime number. And there's no way that you can combine 1 and 5 to get minus 2. Plus 1 minus 5 is minus 4. Minus 5 plus 1 is also, well, it's the same thing, isn't it? Or what else? Plus 5 minus 1 is plus 4. Okay, so we can write off the bracket factorization method, which means we're going to have to use the quadratic formula. Okay, no problem. So we're going to use a quadratic formula to solve x squared minus 2x minus 5 is 0. Okay, I hope you've got the quadratic formula committed to memory. It is x is minus b plus or minus square root of b squared minus 4ac all over 2a. Memorize that right now. Okay. A is that number, is 1. B is that number, is minus 2. C is that number, which is minus 5. Okay, stick them in. Therefore, x equals minus b. Don't make the double minus mistake. Minus b is minus, and b is minus 2. Minus 2. Okay, it's minus minus 2. Plus or minus square root of b squared. Minus 2 squared, b squared. Minus 4 times a is 1. Times c is minus 5. All over 2, I'm rushing to a. A is 1, so that's just 2. 2a, a is 1, 2 times 1 is 2. Okay? Therefore, x equals minus minus 2 is plus 2. Plus or minus square root of minus 2 times minus 2 is 4. Minus 4 times 1 is minus 4. Minus 4 times minus 5 is plus 20 all over 2. Therefore, x equals 2 plus or minus square root 4 plus 20 is 24 over 2. Okay, the square root of 24 is going to be slightly less than 5 because 5 times 5 is 25. So we can discount the negative solution because x has to be a positive value. Okay, so x is 2 plus root 24 over 2. Now, this is the step that separates the chumps from the chaps. It's tempting to stick that in your calculator right now and get the value of x, which turns out to be 3.4494A something something something. Okay? You can do that and get that in your calculator's memory and work with that for the rest of the question. However, the best way to do this question is not to do that at this stage. We've still got a lot more work to do, okay? And we want an exact value of x. If you look at this, it can be simplified using our surd skills, okay? It's better to leave it like that in the form of a surd. Ideally, in any question, you only want to calculate, to put the thing into the calculator and get the exact value at the very last step. Okay? So, x is 2 plus, remember we're discounting the negative solution, root 24. Square root of 24 is, well, 24 is 6 times 4, so square root of 6 times the square root of 4. All over 2. Okay? Therefore, x is 2 plus square root of 4 is 2. So I'm going to write root 6 root 4 as 2 root 6. All over 2. Okay? So therefore, x is 2 divided by 2 is 1, and you've got 2 on the top, 2 on the bottom, so that leaves just root 6. I much prefer that version of x. X is just 1 plus root 6. Let's work with that and then only put in numbers into the calculator at the very last step. Okay? So, we've got x, it's 1 plus root 6. Where do we go from here? Well, we want to find the perimeter, which means we need to know distance from there to there, the hypotenuse. Let's call it h, we can call it whatever we want, but h seems sensible. How are we going to work out the hypotenuse in terms of x? Clearly, Pythag, it's a right angle triangle. So, h squared is that squared plus that squared, which is x squared plus x minus 2 squared. X minus 2 squared, okay? So, therefore, h squared is x squared plus, remember that is not x squared and then minus 2 squared. Don't fall into that trap. It's x minus 2 times x minus 2. Okay? So it's x squared plus x squared minus 2x minus 2x plus 4. Therefore, h squared is x squared plus x squared is 2x squared. Minus 2x minus 2x is minus 4x plus 4. Good. Therefore, h squared is, we're going to sub in the value of x. 2 times x squared, that's 1 plus root 6 times, I'll write it out straight away, 1 plus root 6, that's 2x squared. Running out of space, irritating. Minus 4 times x is 1 plus root 6 plus 4. I'll push on. It's okay. Okay. Right. So, therefore, h squared is 2. I'm leaving that alone. I'm not trying to multiply all three at once. I'll just do this thing first. 1 times 1 is 1. 1 times root 6 is root 6. Root 6 times 1 is root 6. Root 6 times 6 is 6. Minus 4 times 1 is minus 4. Minus 4 times root 6 is minus 4 root 6 plus 4. Okay, that's nice. Minus 4 plus 4 is gone. Therefore, h squared is, I'll do 2 steps in one here just to save space and time. That's root 6 plus root 6 is 2 root 6. No, I won't. No, I won't. I'll take that back. I'll gather terms. I'll be good. 1 plus 6 is 7. Root 6 plus root 6 is 2 root 6. Minus 4 root 6. Okay? For h squared is 2 times 7 is 14. 2 times 2 root 6 is 4 root 6. Oh look, that's nice. Minus 4 root 6. Boom, boom. Therefore, h squared is 14. Therefore, h is root 14. Good. Okay. So that's root 14. Right. I've run out of space. So hold on a sec. Okay, we found the hypotenuse, it's root 14. We know x, it's 1 plus root 6. So now we can find the perimeter. The perimeter is just the distance around the edge of the triangle, so hypotenuse plus that plus that. So the perimeter is the hypotenuse plus this, which is just x, plus this, which is x minus 2. Okay, so the perimeter is hypotenuse, x plus x is 2x minus 2. Okay, so the perimeter is, the hypotenuse is root 14 plus 2 times x. X is 1 plus root 6 minus 2. Okay, so the perimeter is root 14. 2 times 1 is 2. 2 times root 6 is 2 root 6 minus 2. That's nice. Plus 2 minus 2. So the perimeter is root 14 plus 2 root 6. And now we're ready to put it in the calculator. The final step. We've got the exact value of the perimeter there. This is why I wanted to work with this value of x through the whole question, rather than this ugly decimal. Can you see how it's turned out much nicer than if you had to keep going to a calculator and the memory recall button to get that? So, Stick that in your calculator and it will give you the exact value, which turns out to be 8.640636 something something something. Now we asked for the answer to 3 significant figures. 1, 2, 3, so that's up to there. So to 3 significant figures, that 0 leaves that 4 alone, so it's 8.64 to 3 significant figures. And that is how you should do these questions. So we've done it, but I just want to say, looking at the mark scheme for this exam, for some reason they also accept 8.63 and they would also accept 8.65, which are both wrong. Using this surd technique and getting the exact answer, the exact value of the perimeter to 3 significant figures is 8.64. It's not 8.63 or 8.65. And yet, apparently, you will get full marks if you write 8.63 or 8.65. You'd get these numbers if, or one possible way of getting them is to use this value of x, but not put in the whole full number into your calculator's memory. To maybe just put in 3.449 into and use and work with x is 3.449 for the question, throughout the whole question. That's exactly how you get the wrong answer at the end. That's why I wanted you to learn this method and work with the exact value of x, because there's loads of more work to do before you get to the end. The more you work with a slightly inaccurate value of x, the more likely you are to end up with the wrong answer. Okay, that's why this is the best method. You can get the exact right answer by putting in the full value of x into your calculator's memory, but it's still inferior. It's better just to know your surds and work with the exact value of x on the piece of paper. You only want to be picking up your calculator at the very last step, okay? So, I'm surprised they're rewarding incompetence. You can get full marks for being incompetent, according to the mark scheme, which I disapprove of. 8.64 is the correct answer, and that's that.